No, that's not what I want at all. There we go.
Okay, let's see. Everybody should have that. All right, let's do this. Let's go to the calculator. Now, let's do some real quick stuff. There. No. There. Okay. Here's all the data. How do I sort it? Somebody help me. I don't know what the hell I'm doing. How do I sort it?
Stat.
Stat?
Sort A.
Shit, yeah. I know all that sort.
L1.
Thank you so much. I love that. So now if I go back in, it's all in order. So obviously you can make a stem leaf easy as shit. You can make Instagram, all that kind of stuff. What I want to know is what is the 17th percentile? So how many data points are there?
20.
20. You guys take a minute. You guys remember how to do it? How do you figure out there's a two-step process, right? Oh, there you are. Well, you can work. What was the first step?
You take 0.17, because you're finding the 17th percentile, you said?
Yep.
Times 20, because there's 20 variables.
20
which
data
is
values. Yeah.
20, yeah.
And no, this is not picking on you. This is a really good point to put this. How many variables are there? One. There's one variable that has 20 possible values. That's going to become big later when we have more than one variable running around. But yeah, so we got 20. So does this make sense? Please just let this make sense. If I want to find the 17th percentile, and it's supposed to be the number that has 17% below it, am I not just going to go 17% into the list? 17% of the way? Well, the whole way would be 20. I want to go 17% of that, right? And what makes me really sad nowadays is people come out of high school not knowing what the word of means mathematically. You guys know that of means. What does of mean mathematically? 17% of 20. What would I do? You already told me, but in a 0.17 times 20? Yes?
Yeah.
Yes? Okay. Of means multiply. If I had 3 crates of 5 apples each, I'd have 3 times 5, 15 freaking apples, right? Okay. What is 17% of 20?
3.4.
3.4. Now somebody else tell me, what does that mean? What do I do? Yes, if I get anything besides a whole number, I round up and take that number. So this kind of kicks ass, because I can just round up. What is the fourth number?
67.
Looks to be 67. Now this day is a little weird. The book is a little overly careful with repeats. Who cares? Doesn't matter. Small set of data, it really doesn't matter. All right, now real quick. Let's do this together. Q1 means what percentile?
25.
25th percentile, right? Makes sense. First quarter. 1 quarter down, 25% of the way in. So go 25% of the way in. What's 1/4 of 20?
5.
5. What does that mean? Average the 5th and 6th. All right, let me stop for a second. You guys, there's only 2 things that could happen. I do this first step and I get a decimal, round up, take that number. I do this first step, I get a whole number. Average that with the next. That's how you always do percentiles. So what are the 5th and 6th numbers?
68 and 68.
Yeah, it kicks ass. All right, that's 68. 5th and 6th average, 68 and 68 divided by 2 is 68. That's amazing. All right, so real quick, Q2, that's also known as 50th percentile. I get 10. I'm going to do the 10th and 11th, right? Is everybody with me? Are you guys with me?
So, Q1, what does that come to? After the P we put for percentile, where the Q's stand.
Where the what now? Sorry?
The Q's that you put,
Yeah, so if I'm 25% of the way through a basketball game, I'm done with the first quarter. So another word for the 25th percentile is the first quartile.
yeah.
Is that cool? Is that part of your question? I
Yeah.
want to make sure, because they didn't hear part of it, but that's all right?
Yeah, that was
Okay.
good.
There's also these things, we're not going to talk about besides what I'm about to say, then you can forget about it. There's things called deciles. What do you think decile 1 is? Decile 1, decile 2. First 10, I love it, first 10%. So decile 1 would be P10. So instead of breaking up into tens, quarters break them up into quarters. So of course it's 25%, 50%. I like it. So what's the 10th and 11th? You can't see it on my screen, but
They're both 70.
they both said, oh, this data is so nice. Yeah, there they are. You can see it. There's the 10th and 11th. They're both 70. That kicks so much ass. Become the 68. This is a 70. Q3. 75% of 20. 3/4 of 20 is 15. All right, some of you guys are falling asleep, so I'll do this real quick. 15th and 16th, I want to average those.
They're both 72.
They're both 72?
Yeah.
Oh man, Jeff, you're so nice and evil. All right. So what is the 5-number summary? I'm only missing 2 things. Somebody remember what the 5-number summary is?
The
Minimum and maximum?
Yes.
Yeah.
So the low was 60. What was it? 65? I can't remember now. What was the lowest? 65? And the highest was
73.
Was the highest 73? Oh, okay. Oh, yeah, that's right. I thought these were grades. No, these are heights of people. Thank God. All right, now real quick. So that's my 5-number summary. Any questions? I went a little bit quickly. Sorry. Yeah, you can ask questions. What can I do with a 5-number summary? I'll tell you what you could do, Jeff. Huh? Box and whisker. Remember, it doesn't matter if these numbers don't show up at all. It doesn't matter. Where are my numbers? You don't care. Get out of here. I don't want to. All right, there's my numbers. 65, 68. So 65, that makes sense. Let me start at 65. I only need to make it up to 73. So maybe I'll go by 2s. You know, by 1s really though. And then I just gotta, what do I put on there? Do I put a little circle? A little open circle? A little
No,
close circle?
lines.
Lines, there you go. This is where Jeff unfortunately said to do lines, but you know what Jeff means, so I'm not condoning certain activities. And then 68, and then 70, and then 72, and then 73. So as long as your scale is consistent, somebody else could have an entirely different scale, but the shape will be the same. That's why you want a consistent scale, so it always makes a consistent shape.
And
Now-
you don't want to do, per se, like 73, 65, 72, you want it to be in increments? I don't think I'm saying it.
Oh. This has always got to be constant.
Okay.
So what kills me is when people do, you know, they'll do 65, 68, 70, 72, 73. I'll get this out all the time. I'm like, what the shit? What the shit? I don't know. You guys understand what I'm saying?
Yeah.
This is the quickest way to make a science or a math teacher cry, is to not have a consistent scale. Let me show you something really cool. We got all the data in the calculator, right?
Time to move it.
Okay. I don't want to have to start paying you or something.
Good,
I don't have that
'cause
much.
Charge.
I don't have that much money, no matter what you charge. All right. Now, watch this. If I do this, you're going to see a lot of weird shit in a minute, but I'm going to show you this right now. Go to calculate. And again, what did I just say? How many variables did we just put in?
500.
No. I love you guys. I love you guys so much.
1.
There's one variable. In this case, it was heights of people. There's one variable that has 20 values that we discovered which values corresponded to those. But there's one variable, heights. I like it. So I'm going to do one variable, statistics. And you're going to tell it which list you're going to do. Does anyone, if you click one variable, stats, does anybody have something different show up on your screen? Does anybody? No, everybody's got that? It's okay if you don't, just to make sure you understand.
Wait, I forgot how you got there.
Let me show you. So go to stat. And this one is where you enter data and do very basic shit. And if you want to calculate something more, you go to calculate. And now you calculate one variable, statistics. Tell it the list. Don't worry about the freaky stuff. I don't have a frequency list, right? I didn't make a frequency distribution, so I can just calculate. You see anything up there that looks familiar? Anything?
Yeah, X bar.
All right, X bar. Somebody else? Well, actually, what's X bar mean?
X bar is, give me 30 seconds.
Okay, you look it up. Anything else look familiar? Any other symbol?
Sigma.
Sigma. I love it. Sigma looks familiar, John. You just told us about it. What does it mean? What does sigma mean? Sum of. Yeah, so this would mean what I get if I did what? This would be what I would get if I add all the numbers up.
X
right?
bar is sample.
Sample what?
Yeah. Wait, sample of what? I
No,
don't know.
it's X bar is the sample. What? Mu is the population blank. X bar is the sample blank. Mean, otherwise known as average, right? X bar is the sample average, or mean, and mu is the population mean. You guys okay?
Okay.
You're with me?
Yeah.
Mu again?
It's not up here, right? But mu would be the symbol if it was a population.
The one that kind of looks like a U.
Yeah, it looks like a U with an extra leg at the beginning. Mu. All right. Don't worry about these. We'll talk about these today a little bit. Well, we'll see. I don't know. Jeez, I'm a little behind. Sorry. Now look at the bottom. Look. Minimum Q1. It's saying there's more shit. What happens when you scroll down? What are those last 5 numbers? It's a freak 5-number summary, right? Yay! I could just do that. No, you can still do the work. Of course, you must, or else I would take all your points away. But you can double check yourself. Shit, yeah. Right? So the work is not telling me what buttons you pushed. That's telling me what you did to make the calculator do the work. The work is this. Yes? Okay. I like it. I like it. Okay. So we also last time didn't we discuss mean, median, mode? Yes? Remember that?
Yeah.
The mean was, of course, the average. That's where we talked about the summation symbol, the sigma. The median was the number in the middle, but they have to be in order for it to make sense. You guys with me? All right. What's a median also known as? Something earlier we talked about. We just did it today. What's the median also known as? What number would be right in the middle? The what percentile?
50th.
50th percentile, right in the middle, yes? Okay. I think that's where we left off. And the mode, of course, is the thing that occurs the most, and it works for non-quantitative data. Jeff, can you just speak English? Yeah, it works for non-numerical data. I can't speak English. I got to stick with math. Yes?
So like, say like, because there's sometimes where like, it's an odd number of
Yes.
numbers, so the median you would divide.
That kicks so much ass, because then there's a definite middle, right? If there's an odd number of numbers, there's a definite middle number. It's when there's an even number, you got to average the two in the middle. That's when it sucks. Yeah. But again, you do exactly like you do. How do you find the median? You calculate P50, because that's what it means. Does it make?
Yeah, but then like, so my question was gonna be like, say you get like a decimal percentage for the middle part, how would you do that?
If you get, I'm sorry, if you get what now?
So like, say like for Q2, the middle part, say it's like a decimal percentage.
Oh, you mean on this step or this step?
On 2. Say it's
Here?
like a decimal, yeah.
Oh, then I would have estimated where it was here.
Okay,
If it was 70.8, I would have put this bar a little bit more over there, right? Because it would have been closer to 71, is that?
Yeah.
That's all, yeah. So these were nice because I had nice data, right? Okay, I love it. All right, so what we're about to do is what I have a whole group work thing about, but we don't have time. A whole group work thing, and I'm not gonna do this because this is fine, but it's, let me just show it to you, why not? My poor little group work. Scheisse. There we go. So, holy. So I was gonna make you guys calculate the mean, median, mode of these. And the mid-range, I didn't talk about the mid-range, did I?
No.
That's fine, I just don't have to. So I'll tell you, the book doesn't have mid-range, so I'm not, but I did discuss it before with other classes before, but what do you think the mid-range is? It's the middle of the range. It's crazy, mid-range. So how would I find that? I would take the low plus the high divided by 2 to find the middle of the range. That's what mid-range is. Why is it kind of evil? Because range is high minus low. Mid-range is high plus low divided by 2. You guys understand where people can make mistakes with that?
Yeah.
Okay, so I'm not going to ask you about it because it's not in the book.
Okay.
So don't worry about it being there. Hey, mid-range. Just let it be there. So the point of this whole thing, can anybody look at this and kind of tell me, do you understand what's happening here? Like, I'll tell you the average for A is 13. Anybody have a quick guess for B? What's the average? 13, because do you see how I made, really real quick, do you see how I made this 13 go to 14? Right there. Do I have a laser? Sometimes I have a laser. No. And I made that 13 go to 12. I made that 13 go to 15. I made that 13 go to 10. I mean, so I kind of did that whole thing. So it comes out to be the same mean. So the whole point of this is when you do the means, they're all 13. When you do the medians, they're all 13, right? You can see that. 13's in the middle of every one of them, you would think. When you do the modes, they're all 13. And the mid-ranges, they're all 13. So the point I'm trying to make with that exercise is just knowing the center doesn't differentiate data sets. Would you say those 4 data sets are the same?
No.
Shit, no. Right? Which one? Is everybody, let me make sure, you guys kind of with me? Oh, some of you guys are like, time, can't you go faster? All right, stay with me. Yeah, some, they're on. Everybody looking at the clock. Okay, get out of your system. Okay, now, which one of these sets of data is more spread out? Which one's the most spread out?
Group D.
As in what?
Group D?
B as in banana?
No, D.
D as in
dog.
dog. Any other, does anyone agree, disagree? Somebody's give me a thumb up, okay? I'm gonna take that to mean agree. And the rest of you are all like, Mega, stop. You guys all right? I'm always worried about you guys. You guys doing okay? Is it making sense? You're like, just go to the next thing. Okay, I'll go, okay. All right, so what I want is the average kicks a lot of ass. Do we all agree? Sometimes the median's a little better, but most generally the average is the thing I want to know immediately. Right? What's the average age of this place? What's the average grade they make? Well, I mean, I want to know the average. Give it to me. There's one more number that if I knew those two, I don't even need to be told all the data points. I have kind of a good idea of what the data looks like. And the other number is the spread. Remember I told you on that, when I told you the quiz grades, there was a spread number and expected to be about 14 for a quiz, and it was 19 for this one because it was so A's, B's, and F's, so it was a huge spread of data, right? So I want to construct a formula that will give me a number that tells me how spread out the data is. Now somebody help me out. The people that thought group D was the most spread out, why did you say that? Or anybody else, if you agree, why is group D the most spread out? What is true about the other ones? That's not true about group D as much. What's the average for all of them?
13.
13. Think of 13 as home. Which one has elements that get the hell away from home more?
The numbers in group D are lower but also higher.
Good, so they're further away.
Yeah.
Let me say that again. I want this to make sense. There's a few different ways we could have defined spread. But the way we decided to, it kind of makes sense. It's related to the most important number is the average. So I'm gonna measure spread based on the average. Which one gets away from home? Anybody have more than one child? No? Anybody have one child? Anybody in a family of more than one child? All right, some of you guys. I had 3 siblings. Anybody have more than that? We had 4 kids in our family. You guys, yeah? Now, pretend like you're a parent. What does your parent want you to do when you get older? They probably want you to just go, right? I don't know. It depends on your parents. So, all right, I'm sorry. This whole analogy is on. I think of the mean as home, and so that means the spread is which data has values that get further away from home. You with me?
Mm-hmm.
So my parents live in Virginia. I got pretty far away from home, right? I can go visit, it's fine. Okay, now, so let's focus on this. Let's build this up. This is going to be exciting. This is sort of like watching sausage gets made. That's not exactly exciting, Jeff.
What?
Watching sausage get made. So you guys don't get to watch equations get made very often, but we're going to do this together. We're going to create an equation together. Get out of here. Here we go. Come here. Okay. So let's see. Let's get this definition pinned down for this thing. I'm going to formalize the name of this. Some of you guys probably already know the name of this spread. I'm going to call it spread for now. So I want the definition of this. The definition is going to help me figure out what to do mathematically. And I want us all to kind of agree with the definition. The definition of this should be, I want the spread to be a number that tells me the average distance from the mean to all the data points. Wouldn't that capture what we were saying before?
Yeah.
If they get further away from the home, on average, the S number should be bigger. The number that calculates spread should be bigger, right? Mm-hmm. So obviously group A is going to have a very, very small spread number because only 2 of the kids got out of the house. Okay. So let me say this again. We want the spread to be the average distance from the mean to all of the data points. Shivas, what in the all the data points. How do I calculate the average anything? If I wanted to know the average shoe size in here, what would I have to get first?
The shoe sizes.
A list of shoe sizes. If I want to know the average
Height.
what would I need first? A list of
Height.
heights. Crazy. So here I want to know the average distance from the mean to all the data points. Okay. Which means I need a list of distances from the mean to the data points. Does that make? I really want this to make a lot of sense because that's how we know how to calculate an average. It's the sum of stuff divided by sum of distances. Good Lord, Jeff. It's mildly English up here. Divided by how many there are. So now we got to formalize this a little bit, of course. Distances doesn't work too well in a formula. Aw, sound like he cried. All right. Why did a math teacher have to buy? Shut up. So, let's get some data. I'm going to give us 2 sets of data. What do you got, Jeff? I wish I knew. There you go, buddy. Let's make a smaller set, sort of like those. 2, 5, 5, 5, 8, and 2, 3, 5, 7, 8. Okay, this is so exciting. Which one should have a number that represents spread that's bigger?
2.
Good, 2, right? Is that cool? It has more data points that get away from its mean. On average, they get further away from the middle. Okay, so let's do this first set of data. Let me write it like this. Just be weird. What's the mean of those? What do you guys, I kind of made it come out to be a certain something.
5.
Can you guys see that the mean is 5? I like it. So tell me this, how do you get the distance between the mean and each data point? What would you actually have to do?
Count.
What if my numbers were 18,347,500,000? I don't want to count yet.
Set them from smallest to largest.
Already did that, but I don't have to. What's distance mean? And
Subtract.
Subtract. I like it. We'll stop there. Subtract. So if I do, let me see if you guys are cool. So how far away from the mean is this? It's 3, but if I subtract, I get, of course, -3. It's going to be a problem in a minute. You guys with me? So that means it's 3 down. Is that cool?
Yeah.
That's 3 below the mean. So what am I really doing? I'm going to do that each one, right? So I can put up here a rule. I'm going to take each x, and from that, I'm going to subtract, and let me say this right now, this is a population. It's a very tiny population. Cool. Some of you guys, you always think the population's got to be big. Population can be 2. Here, the population is 5 big. Let me stop for a minute. Okay, so now if I keep going, I get a list of sort of distances here. All the zeros, of course, capturing the fact that it's got a lot of stuff that stayed home. Maybe. What do I get? Now, of course, I've got my distances. If I add them all up, what do I get?
0.
If I add this up, all up, no matter what the data points are, I'm going to always get 0. Because the mean is right in the middle, so I'm going to have equal amounts negative to positive. That sucks. Thanks, Jeff. Taking us down this nowhere path. Jerk. So, one thing we could do, this is what I was hoping somebody would kind of yell out earlier. I don't know if anyone was thinking this. What really means distance in math? I love you guys. There's a function that's always positive because it means distance. Anybody remember? What do you do something to? I almost made the symbols. What do you do something to make that number always positive? You take the, no? I thought that would give it away.
You like put it on the top?
Oh, you put it in the little lines. I don't know what it's called, but you put the 2 lines around the X.
Absolute value?
Absolute value. I like it. Like, you could call it the little line function. I like that. Now, all right, stay with me, guys. Stay with me. Kind of quickly. I'm almost certain that nobody remembers this, but does anyone, by the way, remember what the graph of this looks like? Real quick, what's the absolute value of -1?
1.
1. Absolute value 0 is 0. Absolute value 1 is?
1.
1. It looks like this. If this is the trajectory of my plane, is this a plane you want to be on?
No.
Thank you for flying. What the shit airlines? We're about to take a big ass. We're all dead. We're all dead. So what I'm trying to say, mathematically, we don't like kinks like this. Like this. Not any other definition of it. It gets weird. So that's one reason. That's not the only reason. That's one reason we decided not to use this. What else can we do to make something positive instead of absolute valuing it? What else can I do very simply to make it always positive?
Add
No.
Part of me wants to say multiply it by -1, but then that would make the positive values negative.
Exactly.
So,
Square it.
Square it. And I don't know if you guys remember. Anybody remember? Anybody remember how to talk? Anybody remember what an x squared looks like? Can anybody draw in the air for me? X squared. Start with a P. What does that look like?
a U.
A U. Isn't that a plane that you'd much rather be on if you had a choice? Which plane you want to be on? I want to be this plane because I have a chance to survive that turn. This plane, we are all very dead. Can't survive that sudden turn. Okay, so what we do over here then, what does that mean I'm going to have to do at the end? Of course, if I square things right now to kill the negatives, at the end I'm going to have to
Square root.
square root, because if these are pets people own, maybe dogs people own, this is going to be square dogs. I don't want to meet your square dog. I don't know what that means, so I better square root at the end. Yes, maybe, no? So I've got to square, because there are problems with this function that we don't want to use it, so we got to square is the next best thing, but that means at the end I've got to square root. So what do I get when I square these bad boys?
9,
9?
0, 0, 0, 9.
Oh man, I was going to do those. No. All right, I really want you guys still with me. This has gotten a little worse than just finding the average height. When I just get a list of heights, add them up, divide by the measure? Yes. Here, there were a couple of problems. It was distances, there were some negatives, oh shit. But don't we basically have a list of all the distances squared? Could I find the average squared distance?
Yeah.
What would I do with these?
Add them up.
Add them all up,
Divide
and then
by how many there were.
divide by another. So what's the symbol I use to represent what this sum is? This is 18, but what's that symbol? What did we just do? What symbol do I use?
Sigma.
Sigma. And what did we just add up? What things?
Mu.
These things. Isn't this what these are? Maybe? No? Yes? Maybe?
Yeah.
Okay, that's why you always want to label these bad boys. Jeff, enough of the bad boys. What are you going to do when they come for? Yes,
You're recording, right?
I think so.
Mm-hmm.
Is it? Yeah, okay. See, you're in the front row, you gotta help me with that camera, okay. And now, sorry, we did some weird shit, we did. I need to make a list of distances, stupid negatives, okay, square them. I still wanna find the average distance, so I've gotta kind of compromise. I'm gonna find the average square distance, which I do the same way you always do. Bunch of freaking square distances, add them up, divide by, in this case, 5. Isn't that how we find the average? I got 5 of these. How do I find the average? Add them up, divide by 5, right? So what's the formula for what we're doing? I do this divided by n. Yes?
Kind of this is a dumb question, but what does the little e mean? That means the sum?
Yes. Yes. Do you guys remember we had a whole little session, wasn't it last time? Just focused on the summation symbol. Do you guys remember that? Sum of x squared. You weren't? Do you?
No, I wasn't here.
Oh, okay, okay. So it's a good video to watch. This isn't the answer to this number we want yet, is it? Because I haven't square rooted yet. So what it's going to be, it's going to be, remember this is a population, right? So it's going to be a Greek letter here. It's going to be the Greek letter S, which looks like a fat R. Start at the chin, come around the corner to the neck, whatever you want to call these things. This is the belly. Start in the middle. Start here, come around. Depending on how I feel, it's skinny or it's fat, depending on how I feel. So those are all sigmas, lowercase sigma. This is uppercase sigma. Where'd you go, uppercase sigma? And that's lowercase sigma. So this is not the number we want yet, because I got to take a square root. This is called the variance. Oh, Jesus, Jeff. What's up with all the terminology? That's the variance. That name kind of makes sense, is how much the data varies from the mean. Okay. So look, I really want you guys, see how this says sum a bunch of stuff up divided by how many there are? Isn't that an average? That will average whatever these things are. So let's see what we got so far. What's the variance then? What's the sum of these things?
18.
18. And there were 5 data points. The quick way to divide by 5 is double the top, move the decimal back once, 3.6. Or do it in the calculator, right? Can you still see me? I don't know.
Yeah.
Poor little dude.
Yeah, I got a wide ass thing going on. Okay. Focus. Okay.
And then how do I get the actual spread number? What do I have to do
Square
still?
root.
Square root. So somebody help me out. Jesus. Not Jesus.
I don't know. Sometimes it doesn't turn on.
I don't know either. Where's my calculator? Are you my calculator? Yes.
1.897366596.
Can you be more specific? So here's what we do. For this, which let me give this a name finally. This is called standard Jeff. Not standard Jeff. This is called standard deviation. Does this sound familiar to some of you guys? Standard. No, it's okay if it doesn't. That's fine. Some of you guys have seen a little bit of stats before. And I already forgot. It was
897.
1.897. This is perfect because I always want standard deviation at least 3 decimal places. Tomorrow, at least 3. The day of the final, at least 3. Because that, for the most part, doesn't allow for rounding errors to come in. Now, if my data, the reason why I say at least 3 is if my data was all like this, I would probably want my standard deviation more decimal places, right? So if my standard deviation came out to be 0.00002, and if I do it in 3 places, it's 0. Well, that's a lie. So that's why I say at least 3 decimal places. Okay, maybe. So, what I want you guys to do is to do this. Set that up here. See, I'm going to let you get a little bit ahead of me and then I'll catch up to you. Remember, our prediction was this guy's spread should be more than that guy's spread. So we should get a bigger number than 1.897. Everybody realize the mean is still 5. Be really careful. That is the only reason we're subtracting 5 here. If I have a different set of data, don't subtract 5. You got to subtract its mean. You guys getting these numbers here? So what's gonna change over here? This will be 26. And then 5.2, so we would, okay. So this is 5.2. It's definitely bigger than that. 2.280?
Yeah.
All right, so it did its job. It differentiated between the two. Before I do this, even the range is the same, yes? The range is 6 for both. So now, if somebody just tells me the mean and the spread, I have an idea of what the data looks like. All right, so if on a test, I tell you the mean was 75 and the standard deviation was 2. Did anybody do really well? The mean is 75 and the standard deviation is 2.
No.
No, right? The average distance from the mean, 75 to all the data points, is only 2. There might have been one person maybe, but then everybody else had to be stupid close to 75. Are you with me? If I get something like that, that makes me concerned, because it might mean everybody made the exact same mistakes, which means I taught that horribly or something, right? If I give a test and then say the mean is 75 and the standard deviation is 20, what most likely happened?
Some people didn't pay attention.
Some people made big old A's, and some people made big old F's, right? Big old spread of that grades. Maybe? Okay. So I do like to tell you every time I have a test or a quiz, I'll tell you what the spread is, standard deviation, so we get more and more used to it. So let me give you this. I have a, incredibly enough, I have a handout. One side is a fully worked out problem, and the back is one, we'll see. Not picked an effective route. All right, so. So in this example, somebody turn out the one that says whiteboard and inboard. I think that's right. That's okay. This is just another example, right? So you can have a fully fleshed out example, the variance, the standard deviation. Oh, I always forget this. It's amazing. How long have I been teaching this? And I always forget. All right. We just did the standard deviation for a population. Let me see if I can explain to you why it would be different for a sample. The formula is different. Can you guys see the formula that I gave you? Two big differences, right? I had no Greek letters because it's not a population, remember? There's an S, not a sigma. There's an X bar, not a mu. What else is huge, different? N minus 1. What the shit, Jeff? All right. Stay with me. There's an average age in here right now, yes? It just is. There is one. Okay. If I took everybody on this side of the room, who thinks their average age is the same as everybody's? Who would put, I would put a lot of money, remember I'm a teacher, so I have a lot of that stuff. I'll put a lot of money on their average age being different. You guys agree? Any sample, I'm pretty much going to bank on it being different than the whole population, yes? Now, would these people be closer to their own average or closer to the whole average?
Our own average.
Doesn't that make sense? Because their own average came from them. They will be closer to their own average. So whenever I do a sample, if I did it the exact same way as I do for a population, the answer is going to be smaller than it's supposed to be. Because their spread, if they compare it to their own mean, is going to be smaller than it really should be compared to the population mean. Let me stop for a minute. Are you guys semi with me? How do I make a division problem end up bigger? I make the bottom smaller. If I divide by less, am I not left with more? Yes? If I had less people to divide money amongst, wouldn't we all get more money? Yes. Why is it exactly n minus 1, Jeff? So at least you know why the bottom is smaller now. Correct? It's an adjustment because it's just a poor little sample. It's closer to its mean than it would be to the real mean. So to adjust that, I make the bottom smaller. Now, let me talk about why it's n minus 1 a little bit. This is not going to be a satisfactory answer, and I don't care. But I'm going to tell you a little bit. There's a little bit of this story that requires a little more math. But this is enough for you now. And this, what are you doing? This comes up later this semester in a few different places, this exact phrase. So there's something called, well, I'm not even going to tell you. Here's a neat problem. I love it. I will tell you in a minute. I love somebody. So, are you okay? I'm tired. So I'm trying to get through it. Here we go. If I gave you 3 numbers, if I said there are 3 numbers and they average to be 10, do you know anything about the 3 numbers? Do you know anything about each number? Does any of them have to be 10?
No.
No.
They could be.
Could be, exactly, but I don't know. It could be anything. You do know one thing, though. What's the only way that 3 numbers can average to be 10, considering you have to add them up and divide by 3 to get 10?
They add up to 30.
Does everybody understand? Don't they have to add to 30? Because that's the only number I can divide by 3 to get 10. So if I tell you they average to be 10, you do know they add to be 30. So, somebody give me any number for the first one. I don't care.
6.
Oh, sweet. Somebody else give me another number for the second one. 15. Oh, I love you guys. I almost always have a jackass like, square root of 7? 4,720,000. Okay, 15. Can I make up anything I want to here and still have them do what I need them to do? No. How much freedom did I have all 3 degrees of freedom? Right? Did I have all 3 of these? Was I free to make them whatever I want to? No. I could only make 2 of them. Right? What does this one have to be? What do I add up to be so far?
21.
So of course this one has to be
9.
9. Now they added 30. So I had to slow my roll when I got to the last one. So when I have 3 data points, how many degrees of freedom? That's a really strange little phrase, but you get a feel, how much freedom do you have? You don't have all 3 freedom, you have 2. So if I had 18 data points, how much freedom would I have?
7.
17. So isn't it always n minus 1? So what we're assuming is, if you assume let me see if I can make this, I really want this to make the connection. If I take a sample, their average is almost definitely going to be different than the whole average. Yes? Yes. Would you agree that there's one number that if I added it to this group, it would make it the same? Didn't we just see that happen? If I have so many, isn't there one more number that if I knew what that was, the average would be the same? You guys agree with me? Okay, I don't know. Some of you guys are like, I don't know what the shit you're talking about. Really? So it's not the same average. There would be one number, some number that if I put that person in this group, the average would be the same for the sample as it is for everybody. There just is. There's a number that would do that. So this problem is kind of neat. We just assume that we're missing one number. So that's why I don't divide by n. I divide by n minus 1. That's neat. It's still not the complete picture, but what it does is it makes this, if I averaged up all the variances, it would equal the actual overall variance if I divide by n minus 1, not if I divide by n. Okay, so all that shit boils down to this. If I have a sample, I divide by n minus 1. That's an adjustment because it's a poor little sample. Yes? And the beautiful thing is, for a test, I'm going to let you guys have a formula sheet. You're not going to be able to label anything. You can put the formulas and that's it, because that's why it's called a formula sheet. You can't say population and shit, no. But you will be able to put the sigma squared one and the s squared one, maybe. You'll have that on your formula sheet at least? Okay, I love you guys. And just remember, Greek letters means population for now. Okay. Okay, good. So on this side, I have a complete problem that I would normally make you do. Maybe I should. Let's talk about a couple things here real quick. So I did all the work. I got the standard deviation. So here's the thing. Here's what I really want to make a ton of sense. Standard deviation is going to rule our life for most of this course. Basically, starting in chapter 6, it's going to come back with a vengeance. Standard deviation is just the shit, right? And on top of that, so here's what it is. If I had a set of data that looked like this, if I had a set of data that looked like this, right? And you want to, I kind of, you just got to go with me here. I kind of always think about this as, here I am, and I'm walking around the data to investigate it, yes? Do I want to take, if I take really big steps, if my steps are this big, so take one step, don't I miss all the data? Have you ever gone cross country and you kind of blink and you miss a town because you're flying through the town? You sort of blink and miss the speed limits. You got to be careful, right? Has anyone ever done that? There's a town for like a second and then it's gone. And it always, like, if you blink, you miss a whole town. It's gone. Nobody's ever gone cross country road trip? No? And you're all like, dude, I got my driver's license during the pandemic. I'm like, I'm sorry. Sorry, I'm sorry. I don't want to bring that. Were you going to say something?
No, I was saying I did the cross country thing.
You did the cross country thing, but you've never seen, now if you get off the like big roads, you know, these smaller roads, and there's little tiny towns, right? Like there was one near my where I lived, and we'd say, you gotta go down to the strawberry, they had a strawberry festival. Yeah, let's meet at the stoplight. I mean, yes, meet at the stoplight, the one stoplight in town, because it's like gone, okay. So here, don't I want to take smaller steps? Don't I want my steps to be smaller so I can kind of investigate? So, what we naturally choose to be how big our steps are is the standard deviation. It is like a natural unit of measurement I want to use. It's like choosing, if I wanted to see how far apart I am from you, I'm not going to use miles. Yes? That's insane. I'm going to get 0.000. I'd rather use inches. Or if we were in any other country on the face of the earth, centimeters, right? Okay, I like it. So what the shit am I trying to say? Standard deviation, sigma or s, I look at them as step size, how big my steps are. So this problem, it's going to be exciting video at home. All right. Everyone's going to get to see this. This problem here is all about looking at a particular data value and saying how far away, how relatively far away, how many steps is it from the mean? So in this problem, the mean was 5, and the standard deviation I got was 3.536. Does this make physical sense? If I want to know how many steps it takes me to get somewhere, when I say how far away is that thing, divided by how big each step is I take. Yes? Maybe? If I was 5 feet away from something, and each step I take is 2 feet, exactly how many steps do I need to get there? 2.5. 2.5. whoop, and I'm there. Yay! Does that make physical sense? Division is how many of these things fit into this thing. So how many steps fit in between there? That. So it's not even a full step down from the mean. That's what that means. So that thing, that little formula there, let me just tell you this now. I might as well, I'm the teacher, so I might as well tell you what this is. Oh, where the shit my pen is. All right. Showing off my absent-mindedness. Okay. This thing is called the ZScore. That, today is the first day somebody had. Any of you guys ever heard of a ZScore before? Some of you guys I know. Most of you guys know, right?
No.
ZScore. Sounds like some pathetic superhero. I am ZScore. ZScore. That's huge. So later this semester you'll be amazed you never heard of it before. All right. So that is a huge idea. So if your Z-score on a test was 2, how do you feel? How should you feel? Good, bad, really bad?
Depends on the score, right?
Nope.
Okay, good.
Really?
Really good, I like that. Why? Because are you above or below average if your Z-score is 2?
Above average.
Above average. And 2, you're 2 full frickin' steps up from the middle. Right? So, sure, holy shit, could it be a 37?
Yeah.
Great, of course it could, but that still means you did really damn good compared to other people. You are 2 full steps above the average, right? It's like Jeff's first grad school test I got back. Did I tell you about that?
No.
I got a 21 out of 45 or something.
Oh yeah, and she said good job.
Yeah, it was a dude, but yeah.
Yeah, you said.
I was like, my heart sank. And then he came back by and he looked down and he's like, good job, Jeff. I'm like, what? What? So my Z-score was great, but the grade was sucky. All right, so one thing we can do is we can use, this is gonna get a little weird, and you're all like, gonna get weird? So I said, this whole thing, this whole process is me trying to figure out if I go 1 step up and 1 step down from the mean, so let me be more specific, 1 standard deviation up, 1 standard deviation down, how much data do I catch? That doesn't that feel a little bit like, this is a bit of a stretch, but like a box plot, sort of like what I'm catching in the middle?
Yeah.
A little bit? It could be 0%, because my data could look like this. My data could look like, yeah. So what's 1 step up and 1 step down? I didn't catch anybody. Right? In fact, I'm going to use this exact example later this semester. This is going to be our alternate universe Florida of only young people and old people. It's like a weird Logan's Run middle thing. I don't know if anybody's ever heard of Logan's Run. Huh? That's already Florida. Yeah, I know. It doesn't. You don't have to go too many universes over, right? Which Kang variant is there? But oh well, we'll find it. Yeah, so that's plenty. So I think the other side. Oh shit! Huge thing. So the other side we'll probably do first thing next time. Here is a practice test that I will have an answer key to. Oh shit, you know what? That doesn't matter, Jeff. I completely forgot that I put this up in Canvas, but here's a hard copy. I was trying not to use too much paper, and then I forgot it.
So do this before Thursday, get the answer key prepared?
If you want to. You don't have to do any of this at all. If you don't want to, you can immediately make it into a paper airplane and throw it whatever direction. It's up to you. But I will have the answer key. Yeah. Say again? Say what? The quiz corrections? Yeah, you can do that. You can check them with me before you turn them in. You can check them with a tutor. Yeah, you can do them whenever. It's just whenever it's due by the day of the next test. You can still turn it in after that, but the number of points you get back goes down quick if it's late. Yeah. Don't forget your various IDs and phones